Good day, everyone. And now we are in our fourth week in general mathematics, and we are in our lesson 1 to 3. And we will be discussing today the intercepts, zeros, and asymptotes of rational functions. So, the objectives of this lesson is you will be able to find the domain of rational functions, determines the intercepts, zeros, and asymptotes of rational functions, and integrates rational functions in real-life situations. So for the domain of a function f of x is the set of all values for which the function is defined, and the range is the function of the function is the set of all the values that f takes. For asymptote, that is a line that continually approaches a given curve but does not meet it at any infinite distance. Next is to find the domain, set the denominator or the q of x to 0 and solve for x. And a table of values is a list of numbers that are used to substitute one variable such as within an equation of a line and other functions to the value of the other variable or missing a number. So a graph can be defined as a pictorial representation or a diagram that represents data or values in an organized manner. An equation can be defined as a mathematical statement consisting of the equal symbol between two algebraic expressions that have the same value. Okay, so we have here the illustration of a horizontal asymptote. So if you see this green dashed line, so this is our horizontal asymptote, and the red dashed line is our vertical asymptote. So this blue line, this is our curve, the rational function. So it is approaching to our asymptotes, but it will never intersect to our asymptotes. So they are approaching. So nagapalapit lang siya nga nagapalapit sa aton asymptote lines, but it will never meet or intersect to our asymptotes and the curve. Okay, so finding the domain or range of rational functions. Domain will generally be all real numbers except for vertical asymptotes or wholes of the function, and the range generally all real numbers except for the horizontal asymptotes or wholes of the function. So let's have here an example how to find the domain. F of x equals 1 all over x plus 4. To solve for the domain, we will equate the denominator to 0. So that is x plus 4 equals 0. And then applying subtraction property of equality to remove positive 4 sa left side of the equation para x na lang ang mabilin. So we subtract both sides of the equation by 4. So we have now x equals negative 4. And therefore, the domain is the set of real numbers except negative 4. So again, the domain is always set of real numbers except for the x values that will make our function undefined. So since if x is negative 4 in our function, it will make our function undefined since the denominator will become 0. Okay, so let's proceed to our example number 2. Find the domain of f of x equals 2x plus 3 all over x squared minus 4. So for the solution is we equate the denominator equal to 0. So that is x squared minus 4 equals 0. And we can apply here factoring since our denominator is a difference of 2 squares. So we can make this into x minus 2 times the quantity x plus 2 equals 0. And then we equate each set to 0. So we have x minus 2 equals 0 and x plus 2 equals 0. Solve for x. So x equals positive 2 and x equals negative 2. And therefore, the domain is set of all real numbers except negative 2 and positive 2. Next, we have here to solve for the vertical asymptotes is set the denominator or the q of x to 0 and solve for x. So that is how we find or how we solve for the vertical asymptotes. Just set the denominator equal to 0, just like in finding the domain or the restriction of the domain. Okay, next is the horizontal asymptotes. To find the horizontal asymptote, we compare the degree of the numerator with the degree of the denominator. So we are looking here for the degree of exponent. So you take the highest degree of exponent between the numerator and the denominator. And then you compare if n, where n represents the degree of the exponent in the numerator and m is representing the degree of the denominator. If n is less than m, then horizontal asymptote is the x-axis or y equals 0. So again, kung mas dako gani ang degree sa exponent sa aton denominator compare sa numerator, ang aton nga horizontal asymptote is always y equals 0. So if n equals m, then the horizontal asymptote is y equals a over b. Again, kung parihas ang degree or ang value ka-exponent sa numerator and denominator, kung parehas lang, ang aton yung horizontal asymptote is y equals, then you copy the coefficient beside this variable x. So, kung ano ang number ang tupad sa aton yung x, ang variable x, you copy that number sa numerator and the denominator. So, we have here say a, and then you copy b. If n is greater than m, then there is no horizontal asymptote. But there is an oblique asymptote for that, but we will be discussing oblique asymptote maybe next time. Okay, so if mas dako ang degree of exponent sa aton numerator compared with the denominator, wala kita horizontal asymptote. So let's have here an example. The example, h of x equals x all over x squared minus 4. So you take a look with the variable x. So ano di ang exponent sa numerator x? So yung exponent is 1 and the exponent for x squared minus 4. So ang lantawon niya is ang leading coefficient or ang leading term which is the x squared. And then, ang iyang denominator, iyang exponent here is 2. So, sino may pinakadakong exponent? The numerator or the denominator? Since denominator ang may pinaka-highest degree of exponent, our horizontal asymptote is y equals 0. So, always, gina siya y equals 0 if ang denominator mas dako exponent kaysa sa numerator. Next, let's have number 2. D of x equals 4x squared all over 5x squared minus x. So you take the leading term, which is the 4x squared for the numerator, and for the denominator, the leading term is 5x squared. So you compare their exponents. Sino mas pinakadako exponent? Si numerator or the denominator? Since they have the same degree of exponent, so you just simply copy the coefficients. So what is the coefficient for 4x squared? That is 4. And the coefficient for 5x squared, that is 5. So this is our leading coefficients. So we have 4 over 5 as our horizontal asymptotes. Next, for number 3 is, we have here x squared, our leading term. And x here is our leading term for the denominator. Since the degree of exponent of numerator is greater than the degree of the denominator, so therefore we don't have here a horizontal asymptote. No horizontal asymptote. Okay, now let's try to find the intercepts, zeros, and asymptotes of rational functions. So given f of x equals x plus 3 all over 2x. Okay, so to solve for the y-intercept, let x be equal to 0. And then, So solve for x, and then you simplify. We have 0 plus 3 all over 2 times 0, which will make our function undefined. So therefore, we don't have here the y-intercept. Next is for the x-intercept. Let f of x equals 0, or you let y equals 0 and then solve. So we have now x plus 3, 0 equals x plus 3 all over 2x. Then to remove 2x, we multiply both sides of the equation by 2. So we have now 0 equals x plus 3. Since 2x divided by 2x, that is 1. So 1 times x plus 3, that is x plus 3. Next, you simplify, solve for x. So we have x equals negative 3, and our x-intercept is negative. X is negative 3 when y is 0, or the f of x is 0. So we can write this y equals 0 since f of x is just equal to y. They are just the same. So ang x is negative 3 and the y here is 0. That's why we get the x-intercept negative 3, 0. Okay, next is to find the vertical asymptote. So to solve for the vertical asymptote is equate the denominator equal to 0. So you copy the denominator, then you equate this to 0, 2x equals 0, then solve for x. Since may 2 kita nga tupad sa aton variable x, so we divide both sides of the equation by 2. So we have now 2x squared divided by 2 and 0 divided by 2. So this will become 1. 2 divided by 2, that is 1. So we have now 0 divided by 2, that is 0. So x is equal to 0. For the horizontal asymptote, so you compare the degree of exponent from the numerator and the denominator. So sino may pinakadako sila nga value of exponent? Of course, the same. So parehas na ilang degree of exponent. So 1 ang exponent sang aton nga numerator, 1 man ang exponent sang aton nga denominator, sila nga leading term. So we just copy the leading coefficients, which is the 1 and 2. So y now is equal to 1/2. So that is our horizontal asymptote. To summarize our answer, so we have y-intercept none since f of 0 does not exist, where x equals 0 is not in the domain. Our x-intercept is negative 3, 0. The vertical asymptote, x equals 0, which is the 0 of the denominator. And the horizontal asymptote is y equals 1/2 since the degree of the numerator is equal to the degree of the denominator. Okay, so let's proceed to our last example, number 2. F of x equals 6x plus 3 all over x minus 8. And solve for the y-intercept by letting x equals 0. So all x variable, we make it 0. So 6 times 0 plus 3, that is 0 plus 3 is 3, and 0 times 0 minus 8, that is negative 8. So we have our y-intercept, which is 0. So if x is 0 and the value of y is negative 3. Okay. Next is to solve for the x-intercept by letting f of x equals 0 or by letting y equals 0. Again, f of x is just the same with y. Okay, so 0 equals 6x plus 3 all over x minus 8. So to remove x minus 8, we will multiply both sides of the equation by x minus 8. So x minus 8 times 0, that is 0. Any number multiplied to 0 is always 0. So equals 6x plus 3 all over x minus 8 times the quantity x minus 8. So this becomes 1. So 1 times 6x plus 3. So the answer is 6x plus 3. Simplifying, we have negative 6x equals 3. Since we have still here negative 6 beside our variable x, we will be dividing both sides of the equation by negative 6. So we have now x equals negative 3 over 6 or negative 1 half. So our x-intercept is negative 1 half and the y is 0. Okay, so for the vertical asymptote, letting the denominator equal to 0, so x minus 8 equals 0, so for x, that is x equals 8. Next is to find the horizontal asymptote. So you compare the degree of the leading term from our numerator and denominator. Since our leading term is 6x, and the leading term in the denominator is x, so you compare their exponents. Sino may pinaka-highest exponents? Since they have the same degree of exponent, we just copy the leading coefficient, which is 6 sa numerator and 1 sa denominator. So 6 divided by 1, that is 6. So simplifying our answers, we have y-intercept is 0, negative 3, 8. Our x-intercept is negative 1 half 0. The vertical asymptote is x equals 8, which is the 0 of the denominator, and the horizontal asymptote is y equals 6, since the degree of the numerator is equal to the degree of denominator. Okay, that's all. If you have questions, kindly message me to our group chat. And don't forget to pass your answers on October 2. So you can submit this at the school or you can send it via Google question. Thank you.